All right, so half-life is a term that we use to describe nuclear decay, and half-life is the time required for 1/2 of your total sample to decay. And each atom is going to have its own unique half-life. So if we look at this graph right here, we can see that this is the percent of substance remaining. At time 0, we have 100%, and then at time 1, or the number of half-lives has gone by is 1, we have 50, then 25, then 12.5, then 6.25, and on and on and on. So the decay in half-life is consistent, but it's random, meaning that we can't say that just the edge of a piece of carbon would decay. It would happen throughout the entire system. It does not happen all at once. It goes slowly. And these atoms don't just disappear. They do turn into something else, depending on what type of decay we're dealing with here. So I don't want you to think that these atoms are just disappearing into the ether. They do, in fact, still exist. So there's two different methods that we can use to calculate half-life. I'm going to show you the chart method first. This one is the one that students gravitate towards, especially if they have a harder time with math, which is just fine. So how much of a 100-gram sample will be left after 30 years if element X has a half-life of 10 years? So I'm going to go through and identify everything. Half-life of 10 years, that's my half-life. Our sample size is right here, 100 grams, and 30 years is the amount of time that's gone past. So for the chart method, what I'm going to do is I'm going to draw a chart like this. I'm going to make 2 columns on this side. This over here is my number of let's do this. So on this side of the chart, I'm going to do my number of half-lives. So we'll have 0, 1, 2, 3, 4. This will be the time, and this will be the amount. So at time 0, 0 half-lives have gone by. I have 100 grams. But after 1 half-life, 10 years have gone by, and now I'm going to have 50 grams. These transitions right here, you cut it in half every time. So then another half-life goes by, 2 half-lives. Now I've had 20 years go by, and now I have 25 grams. At the third half-life, 30 years have gone by, I have 12.5 grams. And this is the point where we're going to stop because it's the point that the problem asked us for. So our answer for this would be 12.5 grams right there. Now there is a different method here. If element hex has a half-life of 10 years, how much of a 100-gram sample would be left after 30 years? You can use this formula right here. So you would find your number of half-lives. In this case, you would take the total time gone, 30 years, divided by the half-life, which in this case is 10 years. And I would get that this is 3 half-lives that will go by before we are done with this decay. So then we're going to go ahead and plug everything in. Our original sample is 100 grams times 1/2 or 0.5 raised to the power of the number of half-lives. And then you would plug this into your calculator and you would get the same answer that we just got on the previous page, 12.5 grams. I will give you this formula on any assessment for my class if that's something that you'd prefer to use, or you can use the chart method. Either way is going to work just fine.